And we left off here in the empirical rule stuff, bell curve, and we did a whole lot on it already. And we're going to use it again for another problem. We did this one here, but we didn't do this one. So I'd like to do this problem using the bell curve. Y'all probably already drew all over it, so I'm just going to keep drawing on top of it more. Yay! Is that okay? Let's do it. So a mean monthly utility bill of a city is $70 with a standard deviation of 8. So those are important numbers, and they're wanting to know how many are between this and that, right? So I'm going to go back up to the bell curve, and I'm going to put these numbers in. We got a 70, and then I'm supposed to minus 8, and I'm also supposed to plus 8, because that's that standard deviation distance thing. What would I get right here? Is it 60, 62? Yeah, and then 54? Is it 54? Calculators. 40, 54, okay, and then 40, is it 46? 46, okay, cool. I know this one. What's 70 plus 8? Bam! But then I don't know anymore. 86 and 94, thank you. So those are the numbers that we have for, what is it, bills? How, like, oh yeah, utility bills, okay, are between this and that. And so it would be unusual that we talked about this last time. It would be unusual if you had a bill that's 54 or less. Yeah, that's kind of like the cutoff line right there. And then it would be unusual if you had 86 or more, that kind of thing. So they're wanting it between 54 and 86. Well, we literally just talked about those two numbers right there. Wow. Okay. And so I want to know the percentage between this. Like basically, I'm going to use my color here. I want to know what is all of this percentage right here, add it all up. What do we do? How do we add all that stuff up? Like what would be the answer basically? 95 right there, right? It's already kind of at the top. Woohoo! So, but you could, if you really wanted to, 13.5 plus the 34 plus the 34 plus the 13.5. Guess what? 95. So there we go. Cool. So yeah, 95%. 95%. Well, okay, hold up. It is actually right, but not 100%. If you notice, they're asking for something else. It says out of a sample of 40 households, estimate the number of households. So I got 95% of these households, sure, but then give me an actual number of households. How did I do that with the 40? Any ideas? Turn it into a decimal, okay, and then divide by 100, make it a decimal. Yep, and then very good. Multiply it by the 40. I think, is it 38? Thank you. So 38 households would have their utility bills between this much and that much. Cool. Yay. So that is going to be a thing on the homework where you're going through and you get the percentage, but then all of a sudden, no, I wanted households. It happens, and I just wanted to prepare you for that moment. Okay, cool. All right. Scrolling on. Good. If you'll have questions, you let me know. I'm going to keep scrolling. Scroll. So, brand new topic. Standard deviation. Okay, well, standard score, I guess. Z-scores. And there's this formula right here, which is super important. We're going to use that throughout the rest of the class. A Z-score is just telling us a standardized way of knowing where we are on the bell curve. So my boss has a story about this, and I'm just going to copy it from her. She went to the pediatrician with her daughter and or her son, I can't remember which one, and she found that there was like a chart about like weight and height and all that kind of stuff, and her child scored a Z-score of 1.8. That's what it said on the thing. It said Z equals 1.8. And I'm just making up an example here. And you're wondering, is that a good thing? Is that a bad thing? Where's that, right? And so they're going to do this in the real world. They're going to show like just z equals something. What do they mean? Well, if you go back up to the bell curve, this, I'm going to have to use a different color. Oh, man. Do you mind if I erase? Can I erase all that? Like, it's more of just like a show and tell right quick. Okay, sorry. Here we go. Okay, so right down the middle here. Oh, no, that's too bright. Hold up. I'm very picky. Red. That'll work. Right down the middle, this is z equals 0. And then right here is z equals 1. -1. I'm sorry, -1. My bad. Wrong side. Wrong side. -1. This is z equals -2. On this side, we got z equals +1, and then z equals +2. I mean, it's like it's telling you the whole number of how many jumps you made, okay? And so with the story, right, her child had scored, like, height, weight, whatever, was z-score of 1.8. It's like right here, isn't it? So I'm going to ask you right quick, is that unusual or is that usual? Do you remember? It's usual. Yeah, this right here, this zone right here is usual. So that would be a usual score, maybe a little bit more than, average, but usual. Cool? So now you can interpret just like with one number, z equals, and you can tell exactly where you're falling on the bell curve. Like here, the strength of it is that, like, here I have to compute, have to calculate. But if they just give you z, you're done. You already know. So that just makes it faster. So that's what we're going to look for, is the z-score stuff. Now, this formula is really cool. By value, they mean like the number that they want to give you. Mean is average. Standard deviation is, what they, again, stuff that we compute. So here we go. A certain brand of automobile tire has a lifespan of this much and a standard deviation that. So it mean, standard deviation, and it says that we have 3 different tires selected. What's the z-scores? It's like the boss says, here's 3 tires, test them out, tell me what you think, and where do they fall in the bell curve, okay? There's a part B to this, which I'll explain, but let's get through this. So the first one, I need the value itself, so that'll be the 33,000 minus the mean, 38,000, all divided by the standard deviation, 2100. Calculator. Definitely calculator here. I'm sorry. I know it's in your way. Sorry. Get this out the way. Here we go. Bam. That was fast. There you go. I'm going to verify up here, of course, but 33,000 minus 38,000 divided by 2100. Yep, there you go. Negative 2.38, and that's good enough. 0.38. Okay, cool. Straight up, not too bad. So I'm going to ask, like, on the bell curve, and the way we have it all, cut up and distributed, is this usual or unusual? That would be unusual. Exactly. That's actually like way over here on this side, negative 2.38. And it's unusually small. And so think about this for a second. You're working for like automobile place and judging tires and all this kind of stuff. And the tire claims this 38,000 is the average and a standard deviation this much, okay? And someone brings in a tire that only got this much before it like blew out or something weird, So that would be an unusual tire, right? So either the tire's fault or it's the driver's fault. It's somebody's fault, but unusually low. Make sense? But now you can tell. I mean, you could just look at it as a human and say, oh, well, 33 is less than 38. But by how much? How far? Is that something weird or not weird? Does that make sense? Yes, Chad. Okay, good. Let's do it again. 36, 38. Now, you can tell by looking, it's going to be a negative number. But is it going to be like past the 2 range? 0.95? I'm trusting you. No, but not enough apparently, because I'm still doing it myself. There we go. 0.95. Yep. So on the bell curve, and again, looking at where things are cut up and all that kind of stuff, is this usual or unusual? It's usual. That's a regular old value. I mean, it's still low, but it's not that low. Cool. Last one. Help me now. What's the first number that goes right here? 32. Very good. And then minus 38 divided by 21. Yep, you got it. Just making sure. Just making sure. There we go. Negative 2.857. Usual or unusual? Unusual. Again, if you look at the bell curve, it's kind of like the 2s or more. So in this case, it's like way over here again. Unusual. So on the side, I'm going to do like a little thing here. So if z is less than negative 2, or if z is greater than positive 2, then it's unusual. Then unusual. So 2 is the cutoff line. 2 is the cutoff line. So if you got z-score of 2 or 3 or 4, like those are like increasingly crazy. But if you got a 1, a point something, it's no big deal. Okay, so 2 is the cutoff line. Are y'all feeling me? Yeah. Well, you know what? That's a great question. I'm going to put a little line there now, just because you said something. You know, if it's on the 2, it's hard because it's like continuous data. So could he have made it like just one more mile and it'd have been fine, or can he have just like literally not have made another mile? So it's not going to be ever exactly 2 in the real world. Yes, in the real world. Yep. Good question though. That's an excellent question. Yep. Cool. Let's do another one. So Roger's about to apply for colleges, and we got SAT and ACT scores. SAT, the SAT has a mean of this much and a standard deviation this much. The ACT has a mean and a standard deviation as well. He scored 1350 on SAT and 29 on ACT. Which one is better? This is a great question, right? Because like I don't know, no clue, right? Not by just looking at it. And so we need to do the math. So I'm going to do the z-score for the first one and then a z-score for the second one. And then we're going to compare. So let's do this is the SAT one over here, and let's do the ACT one right here. SAT, what would be the value that I put right here? 1350. Yep, to 1350. That's my value. That's the thing that he had. What's the average? 1026 divided by, yes, 209. Oops. Okay, that's good enough. 209. And we'll compute that in a second. For the ACT, what's his value? 29. What's his average, though? And then divided by? Perfect, perfect. Thank you. Awesome. Okay, let me get a little bit more room on this so I can, okay. So yeah, let me put those in. This is how we would know if, you know, one is better than the other. Perfect. So I got 1.5502, and then I got 1.6667. Now, apparently, he did good on both of them. I mean, above average, I would say, right? Are either of these unusual? No. I mean, good, but not unusual, you know? So which one's better? The ACT's better because it's a little bit bigger. And like if I have enough room. Perfect. So yeah, if we were to draw this on a bell curve, we got 0, we got 1, we got 2. This is all, my bell curves get worse and worse over time. So my SAT is like right here. That's the SAT. But my ACT is like right here a little bit more. So this is better. And there we go. Better. Cool? You see the point of it though now, right? Because just looking at this, I wouldn't know which one's best. And so now we know. We can actually look at it and verify. Yes. Any questions? I'm here for you at any moment. We still have coffee. I made a whole thing for the other class, and they like just left. I was like, I made coffee for you guys. They had like drink the whole thing, so I refilled it, and they just didn't want any more. Okay. So Stephen moved from Illinois to Florida, and his average monthly bill has increased to this and that. That's air conditioning right there, let me tell you. He's curious why. So he's comparing. No, he's curious about, is it relatively more or less? Okay, kind of like, think about this for a second. You got a new house, obviously, too, right? So you're going to another house. Does that house have better heating or better air conditioning than what you had before? I know that you had to blast it more, but is it better insulated? Who knows? We don't know just by looking at all this stuff, right? So we have to do the math. In Illinois, the average is this much and the standard deviation this much, but in Florida, the average is higher, okay, and standard deviation a little higher regardless. So let's compare and contrast. So I've got Illinois, and then I got Florida. Ill and flow. Oh, yeah. So what's the value that I put here for Illinois? 83 is what he had, right? It's these guys up here, right? So the average for Illinois, 85, right? And then divided by 320. Yep. Cool, cool. But his new value is the 102 minus average of, and then 4.0. Yep. Let's test them out and see what's going on here. Okay. Okay. So yeah, we got negative 0.625, and here we got a. I guess I didn't need that Z there. I'm going to erase it now. Looks ugly. No. Not that anything else doesn't look ugly for me up here. There we go. So, what was the question? He was curious about which one is this and that. It just relatively more expensive or less expensive. So, looking at these, he was living in Illinois. Now he went to Florida. Is he paying less, finger quotes, or is he paying more? Well, he's definitely paying more. But relatively, would it be like, let's say he like took that house and like, I don't know, took it apart and brought it back to Illinois or something weird. Oh man, I can't control Z that thing. I'm so sorry. Anyways, the point is, relatively, if you look at the scales here, he's actually paying less relatively. I know that's kind of weird. Okay, so let me just demonstrate. Okay, let me just demonstrate. So we got our bell curve. We got 1, 2, 1, 2, right? Let me do a new color. So Illinois is at negative 0.6, which is like right here, let's say. There you go. There's Illinois. The ill. And then we got Florida, which is at 0.75. We got the flow. But full, my bad. Flow. And then I just got rid of my other one here. The ill. There you go. See how from the average, his is like further from the average now. Yes? So it's kind of like he's paying less in a way. I know that sounds kind of weird. But do you see the point that it is weird? He's paying more, yet relatively less. I know, it's just my job. I try really hard. So I try to make it interesting. But yeah, ultimately, I just, I'm doing what I can. Okay, good. Yay. Okay. So, Chevy Chevs. This is a hard break. Brand new topic, brand new subject. Okay, Chevy Chevs. Can you say that 5 times fast? Chevy Chevs. Chevy Chevs. Chevy Chevs. Chevy Chevs. So yeah, Chevy Chevs. So the difference between what we've been doing in this one here is Chevy Chevs is for like non-symmetrical data, and so it's basically non-bell curvy. It's like not that. It's maybe something that looks like you know what I mean, or maybe like here's another one, like something weird out there. I don't really know what to do now, and so what they go with is a new formula to find out what's going on, and they always use a keyword right here, at least. And so let's just say that you're cruising down the homework, right? Because that's what you're going to do once pretty soon. You're cruising down the homework and you get something wrong, and you're like, what the heck kind of percentage are they looking for? I thought it was 95%. But they're looking for something else. The key word, though, is at least. Okay, if you're going through your homework, you see the word at least, stop everything you're doing. It's a whole new kind of problem. Okie dokie. So that's just kind of the indicator word for Chevy Chevs. But again, it's like weird data, or it might say don't use empirical rule, but probably just the at least. So they got these formulas here, and they kind of sound weird. K is the number of standard deviations. It's kind of like a z-score in a way, and you just plug it into these formulas, okay? So let's go and do that, and it's really pretty easy using these formulas. So assume that a distribution is not symmetric. You see that little key there? So there's something to it, but then does it have something else? Oh, it even says, hey, use Chevy Chevs. That's nice. You'll see the at least here in a few minutes. Oh, wait, didn't I see it? Like right there. There it is. Oh, we did it. All right, so K equals 3.3, and it says, what's the percentage? You see that? There's my formula. P stands for percent. So that's what I'm going to do. P is equal to 1 minus 1 over K. It's 3.3, and then I'm going to square it. This is all calculator. I mean, you could try to do it by hand, but nah. And there you go. We got 0.90817. So percentage-wise would be what, 90.8, I guess. Oh, whoa, Chad. Nuh-uh. What would be my answer that I put in? 91, yeah. 91%. So at least 91% would be within 3.3 standard deviations. Again, it's kind of like a z-score in a way, but I know they're kind of different distributions. You see how that would be far different, though, right? 3 standard deviations for us is like way out there, like 99 point blah blah blah. And so this one, they're just accounting for as best they can. 91, at least 91. Are y'all okay plugging into formula? Okay, cool. Let's do another one. From a sample of 36, mean geysers, blah, 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 use Chevy Chevs, at least. See these keywords? So they give us a mean and a standard deviation. They say what's going on between this and that, okay? What I'm wanting to do is find out how many standard deviations away. Like I said, K is kind of like a z-score. So I want to find out what that is. So in a way, it's kind of weird. I'm going to do z is kind of like K. And so we're going to do the same thing, value minus the mean divided by the standard deviation, okay? I mean, it's practically the same style. Okay, so what would be my value for this? What would I put for value? You can take a guess. Ooh, I love when it's silent. So there's 2 values, isn't there? See that? So what I'm going to do is do one at a time, and hopefully we get the same number. Hopefully. So the value is the weirdest part. When it says mean, well, we have that, don't we? Right there. When it says standard deviation, well, I have that. It's right there. You can see like all the others make sense, but these values are the ones that are like, I don't know what to use. And so look around in a way. I'm saying, what other numbers do we have? And I know we have the 36, but is 36 the same like zone as 0.65 and 3.99? It's totally different thing they're talking about. Does 2.04 and 5.94, does that kind of related to the same numbers? See what I'm saying? So we're looking for the same kind of numbers, and we're mushing them together. If you're confused about like where it goes here, it's that other thing that goes there, okay? These are always preset for you. Okay, so calculator for sure. You're probably noticing that I'm on my calculator, I'm using the parentheses a lot. That's not required. I'm just doing it so it's easier for me to type. So I got -3. Let me try this again. I'm going to do the same thing for the other number. 5.94 minus the 3.99 over the 0.65. And you're going to see an interesting little thing that happens here. There we go. +3. So did we get the same number? Kinda, yeah, kinda. I mean, the thing is that I'm looking at the number of jumps, the number of standard deviations. How far are we on the bell curve, right? So I know it's not a bell curve, but bell curve. 3. So what's my K going to be equal to? Just zoom out. 3. Just 3. Yeah, I got a negative, I got a positive. Don't matter. I just want 3. Yes? 3. So K is 3. K equals 3. Awesome. Oh yeah, now we actually have to do the problem. So if you go back, we actually have to do this same formula from last time, right? We haven't done it yet. All we did was look for K. So 1 minus 1 over 3 squared. That's my percentage. We got 0.888888889. So like 88.9%, that kind of thing. Well, that's cool. Is that what they were looking for? Look around. Be careful. What are they wanting? How many eruptions? You see that? Out of the 36. So what do I do with this number then? There you go. Multiply. You got it. So I'm going to say 0.88888888889. That's close enough. Times 36 is 32. And that's the number of eruptions. Didn't they have the, oh, there's the at least. So yeah, at least 32 eruptions. Okay. Whew. Is that okay? I think we got one more Chevys. He got a PhD for this. Did they do PhDs over there in Russia? Probably. I don't know. They probably don't call it that. Patients coming into a medical blah, blah, blah have a mean weight of this and a standard deviation of that. See how it says this not symmetric? And then later on, you're going to see, there it is again, at least. Whoop, whoop. So between the two weights, between what two weights does Chebyshev's guarantee this much? So in a way, it's kind of like we're going backwards. I have 95%. And again, I'm going to do a bell curve just so it's easier. They're saying that 95% is what we're looking for, all the stuff in the middle. Basically, like what's usual, yeah. So then, what would the weights be as cutoff lines? What would start becoming unusually small versus unusually large? Where are those cutoff lines? I don't know. Why don't you tell me, Chad? Okay, so notice that we have the percentage. If you go back up, there's a formula for that right here. We can find our K given a percentage. And it's just the same formula, but manipulated a little. They kind of like, did algebra. Yee! Like, what is algebra? I don't want to do that again. So K is equal to the square root of, I already forgot it. 1 minus P down here. Yes. Well, we have our P, so that's good. So do I just put a 95 in there? Looks a little weird. 0.95, very good. 0.95 makes more sense, right? In a way, it's like 100% minus the 95 to, create that number. Very good. So calculator, here we go. Square root. 1 over 1 minus 0.95. So 4.472. That's my K value. That's not the actual answer yet. Again, I know it's not bell curve. I'm just kind of making up an analogy here. 1, 2, 3, 4. 1, 2, 3, 4. That's pretty far out there. Okay. It kind of like that. What do I now do with the 4.472 thingy? Right? I need to find a weight. So can you go to the boss and say, hey boss, I figured out how to cut off the line there between, unusually small and unusually large. I got it. We're just going to say if their K value is 4.4 or not. The boss is like, yeah, great job. You're fired. Like, that doesn't mean anything, right? We have to actually get the values. Now, I'm wondering, nope, they don't have them. Dang. I have to give you the formula. That's the problem here. That's why you're wondering, like, come on, Chad, you got to give it to me. I know. It's x is equal to mu plus z times sigma. And you're like, what? The mean plus z times your standard deviation. And I'm using z because that's the actual formula. What we're going to do instead of z is use k. Same formula basically though. So what was my mean? What was my average? .207. Nice. My k, z, k, whatever you want to call it in this particular case, and then times standard deviation of 22.6. Thank you. Calculator. So I had to give you that formula. I'm sad that it's not in the formula book. I thought it would be, honestly, but I guess not. So I got 308.6672. Cool. Does that seem like the cutoff line for unusually large, let's say? Right? Wouldn't that be way over here, the 308? Sound good so far? All right, we're done then, right? No. Well, then how do I get the small one over here? How do I get that? Close. I do have to change something, though, don't I? Subtract. There it is. Because remember how we had on the other one, we had a k value that was -3 and +3. And I just said, hey, guys, we're just going to use the number 3. But what's actually going on is each one of these is a plus and minus. This is a plus minus 4.42, blah, blah, blah. And so I'm going to plug in a negative now and see what happens. Yes, we change it to a minus. Very good. So let's do that. So I got 207.6 minus 4.472 times 22.6. So yeah, 106.533. Yeah, that's fine. Would that sound about like the unusually small category, right? And so again, they're looking for 95%, and it's not a bell-shaped distribution. So they're going a little bit more than normal, technically. So there we go. Cool. Good? Good. Okay. See, we're learning. This is a good thing. Yay. Okay. And I think that's the end of the section. So we got the other section. I think that's the last one we have here. Y'all are seeing that there's a lot of not GeoGebra right now. And that's fine. There's a mix, Sometimes it's all GeoGebra heavy like we did last time. Sometimes it's a lot of by hand. Cool? Here we go then. Let's keep cruising. Unless y'all got questions, I'm here for you. Questions are good. Always good questions. So the thing that I was working on, like I was saying yesterday, I was working with a student in the lab. And now she's probably going to listen to this. Hello. So we were working on quartiles and percentiles and kind of like distances from some place, I guess, like 0. So let's talk about this. And we're going to go on to percentiles too. Do they have percentiles? Where's the percentiles? Did they skip it? Oh, there we go. They're way down here. Okay, so we'll get to those in a second. Okay. So quartiles. What the key word here is quart. Yeah. What does that mean in Mathyland? 4. Yeah, 4 equal parts. So quartiles are quarters. 4 equal parts. And so I'm going to make, I guess I like to make little stories and analogies here. Let's say that I have this awesome sandwich, and it's one of these huge sandwiches. I'm not talking a foot long. I'm talking like a 5 foot long sandwich. Yeah, they make those, bro. 5 foot long sandwich, and like everyone's supposed to have a part of it or something, right? Yeah, but I want to cut it up into 4 pieces. It's gonna be super huge still. So I'm looking at this like 5 foot long sandwich, right? And I'm wanting to cut it up into 4 pieces. So 1, 2, 3, we're done. Is that how you do it? No way. Where do you start cutting a large sandwich like this? What's the first cut going to be? Right down the middle. That's right. We're good at that as humans. We're good at that and finding the middle of things, okay? So this is technically called Q2. I know that's not coming up right here. In fact, oh, there it is, right there. Q2, but they also call it the median, which again means the middle. Q2. And that Q means like quarter. So then I need to cut it some more, right, into 4 different pieces. And so what do I now do with this other half over on this side? Where do I cut it? How would I cut this one? Huh? Yeah, find the middle of that. Exactly, right here. We're really good at finding the middle. As humans, we can just go right in the middle, bloop. And so this is called Q1. And then we're going to cut it again over here, and this is called Q3. Okay, so those are the actual ones that they're going to start using in formulas a lot more. There we go. I don't think there's a Q0 and a Q4, but you got the point there. In fact, if you really want a name for this right here is called the minimum, and this is called the maximum. But we'll see that again here later, okay? Minimum and maximum. So that's how we're doing it, and I think that's what all these words are up here, like you're cutting it in half, cut it in half again, that kind of thing. This interquartile range is actually pretty important. We'll be using it in some of the formulas. So it's simply Q3 minus Q1. What that is in the physical world, like physically, is this space right here. It's that space. This distance is the IQR. I know I wrote right on top of it, but it's that distance between the Q3 and the Q1. That distance is IQR. Now, you might be thinking, looking at my cool Subway sandwich, right? You're probably thinking, bro, that's just like half of the whole sandwich. But the sandwich it's not always a sandwich, okay? Let's just say that, okay? I just wanted to make a nice example there. It's not always so nice and pretty. Okay. Outlier, I don't know. We already talked about outlier a long time ago, right? Give me a small definition of outlier. Yeah, something that throws the whole thing off. I like that. It's really far out there, I don't know what else you want to put there. You just, put that because that's what we're doing. Hey, and moving on. So we're going to use this IQR in this formula that they give us to find out if there is an outlier from this data set. Okay. So we're looking for something far out there, something that's going to throw off the rest of the data, and we want to maybe eliminate it, maybe, depending on what's going on. I'm looking for outliers. Without reading directions, can you tell me if you see an outlier up here? Which one? 11. I like that. That's a good potential one there. Anything else? No? 97, maybe? Yeah. Right, they're all pretty close there. So that's a potential. Y'all are all saying 11. I agree with you. Could I perhaps, just perhaps, be able to tell them the list of outliers? They're just saying, hey, find the outliers, and you're going to type out type in the answers. Could you try 11? It doesn't work. You try 11 and 97, it works. Something like that, right? Could you do this without any other math? Maybe. I want to do it right the first time, of course, just in case. So that's our goal here. Let's go, manual, I guess you can say. So to do that, what I need to do first off is find this IQR. okay? And again, that's going to be the Q3 minus the Q1. The problem here is to find the Q3 and the Q1. We have to cut it down the middle and cut those down the middle, right? But look at our data. It's all mixed up, right? So this is one of those times where I actually have to use I would rather use GeoGebra to just give me the numbers, if that makes sense. So that's what I'm going to do. Like right now, I'm going to go GeoGebra. Now, I know that I was thinking that we wouldn't do too much of this, and I don't think we are. This is just one or so questions. So this is a nice review of what we're doing last time. We do that. Hold on. I want to get like all my numbers there. Okay, cool. Okay. And we went to Classic. So GeoGebra / Classic. And then I click on Spreadsheet. Get this thing out the way. I'm going to start putting my numbers in. Since it's like a video, I guess, since I'm being recorded, should I get like some bumper music? Or maybe like this is the time when I 2x speed it. It's like, and it just plays music like da 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 da, or something like that. Okay, I think that's it. I hope so. I have no clue. If we get it wrong, it's because I mistyped something. Highlight everything. One variable analysis. And then I'm going to click the sigma x. And we got our numbers. This is way, way faster than trying to put it back into order, right? Then cutting them. One time I cut like, between two numbers, I got to find an average now. It's like all that stuff. But here it's done. And so here, Q3, what's my number for Q3? Minus, there we go. So it's not giving me the IQR, but it is giving me everything I need for it. And we can come back to that here in a minute if we need more numbers. So in the meantime, okay, so let's find that. So 65 minus 39 is 26. And that's that distance between Q3 and Q1. Now they're saying use this 1.5 times IQR thing. So what I need to do for the next set, the next thing is 1.5 times that 26 to get the distance that they're looking for. Now I'm going to give you I'm going to show you what that looks like physically here in just a second. So 39. 39 is the number that they're wanting to like spread out from. Okay. So how to do this is we are going from Q1 and we're going to go out. So here, let me give you like a number line kind of thing. Okay. Just give me a second here. So there's Q1, there's my median, and there's Q3. What I'm going to do is I'm going to go from Q1 back this way, minusing 39 from it. Okay. I'm also going to start at Q3 and go this way. I'm going to add 39 to it. And wherever we end up, it will tell me if there's outliers more or less wherever we go, okay? So that's my goal, like physically. But I already have Q1, right? Q1 was the 39, Q3 was the 65, right? So here we go. I'm going to go to find this value over here, 39, and I'm going to minus 39. That's kind of weird. Did you see how weird that was? It's 0. Yay, 0. So like this value over here is 0, okay? To me, that's really weird. We're going to figure that out here in a minute. So now I'm going to go 65, and I'm going to add the 39 to it. That one I don't know. What is it? 104. Yep, 104. No technical outliers, at least according to this rule that they're using, okay? At least according to this rule. So that's kind of interesting. Yeah, they're saying anything. So I'm going to write that up in English. So anything between 0 and 104 is okay. And so does everything here match that? Yeah. I know that's kind of a weird ending. Sorry, but that's just what it is. I'm going to look at what I had here. Oh yeah, that's exactly what I have on my paper. No outliers, question mark, question mark. So, like, I was confused also, but hey, that's what happens. But notice that we suspected the 11, but apparently 11's okay, according to the math. Is that okay? I think we're doing it again for this one. Okay, before we do any math, though, okay? Are y'all okay with this? Can I scroll? We're good? Okay, so before we do anything, I still want to play the game. I know that last time we didn't lose, we lost the game, but I want to see if we can do it here. Can you find any outliers? 70? Oh, 17. Oh, you're right. I see it there. Yep, 17. Anything else? Anything big? 82, 87. Yeah, so that's another potential. Yeah. Well, let's see then. Let's see. So we're going to do the same thing. Back to GeoGebra. Let's do it again. Wonder if it'll let me do it like this. Okay, let's try that. Okay, here we go. 2 times speed. I can't keep doing. I'm sorry. Be kind of funny though. Do y'all 2 times speed videos on YouTube? It's the only way to watch, man. I ain't got time for that. Just show me what I need and go. And then it's almost kind of like weird, and I wouldn't say creepy, but pretty close. Whenever you like 1 time speed them, and they're talking so slow, and this is how I normally talk. Yeah, that's pretty crazy. Oh, did you see what happened? Here, I'm gonna do that again. Look, because my screen is more vertical than normal, it shows it a little differently. When I click this button, it just goes blah blah blah, and I click blah blah blah, and yeah, it's just so weird. But it actually did do it. There's the Sigma X, and I need my numbers. They're right here, okay? So, like, if it doesn't look good, just click it twice or something, and yay! And just verifying, does that average look about right? 54 average? Looks good with me. So, okay, here we go. Let's do the IQR. It's again Q3 minus Q1. Oh, you already got it? 61 minus 45? What is that then? Not 20. Is it 16? 16? Okay, I'm trusting y'all. So then I'm going to go from Q1, I'm going to subtract. Whoa, Chad. No. I have to multiply it by 1.5, don't I? Ugh, forgot about that. Good thing y'all stopped me. Like, Chad, what are you doing? So 24. Okay, so 24 is that distance that we're going. So Q1 minus the 24. I'm also going to go Q3 plus the 24. Oh, we already have those numbers. So 45 minus 24, 61 plus 24. Okay, so what do we got? And, oh, good job. You're better than me. Oh, yes. I'm not very good at this kind of math. They train you in calculus and linear algebra and abstract this and partial differential equations, and then I can't add. It's like, okay, well, good job there, teacher. So anything between 21 and 85 is okay. So the 17 indeed was an outlier, wasn't it? Just as we suspected. And we had also talked about that guy. right? We had thought, maybe that one too. And so there you go. So that's actually the answers. So the outliers, what do we got? Is 17 and 87. Cool. Making sense? Making change? Like dollars, cents? Okay. Since when did you get the sense to have more sense? Oh. Okay, back to math. So I would say like a medium break here, but any questions? Okay, here we go. So box and whisker plot, love this stuff. It uses the Q1, the median, the Q3, and then again we have the minimum and we have the maximum. Put those 5 numbers together and they call it the 5-number summary. Okay, in a way, GeoGebra already does this for us. So let me go back to GeoGebra for a second, and I'm going to make this a little bit better, I think. I don't know. I just kind of covered up my numbers there. That's close. Notice that we have minimum, Q1, median, Q3, maximum. Yeah, it's already there. This right here is the 5-number summary, right there. And so if they say, what's the 5-number summary for blah, 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 it's already done. That's nice. The box and whiskers plot is simply just drawing it more like, graphically, where you have these cutoff lines, and then you just put a box on it because it makes you feel better about your life. So, yay. I know, right? So artistic. So they say for these numbers, draw the box and whiskers. So I need to find the quartiles first, right? What do I do to find the quartiles? GeoGebra for sure. Yeah. Grab it. Okay. And a little bit more room. Sweet. No. Yes. Okay, here we go. So 3, 4, 7, 8, 4, 1, 7, 8, 7, 0, 9. Okay. Messing up again. Don't mess up, Chad. Don't mess up. One variable analysis, sigma x. There's my numbers. And so what I'm going to do is actually draw it on a number line to show just how creative I can be once in a while. Yay, number lines. So let's go from 0. Here, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I feel super awesome. Let's do a green again, I guess. Okay, so my minimum is at 0. That's my minimum. Q1 is at 3. 1, 2, 3. There we go. Median. What's the median? 7. Wow, that's a big jump. Q3 is at 8. And then my maximum is 9. So these are the cutoff lines. I'm going to do median right there. Q3, maximum. You don't have to label them like that. I'm just doing that so it's easy to see. So those are my lines. Those are where I want them. Again, you can label it 3, 7, 8, 9 if you want to, 0 of course. And so I draw a line right here and here, and then I draw a box for these guys, and there you go, box and whiskers plot. And someone got a PhD for that. Yay! I know, right? Wasn't me. It wasn't me. I ain't got that stuff. But you can see that it's not symmetrical, right? You can see that the median is somewhere far over there, and then Q3 maximum. What it's telling me is that the graph is kind of more skewed on this side. In a way, if I were to draw on top of this and show, my graph kind of looks more like this here. Bloop. Right? It's got this skew. It's got this tail over here. So I would say that is skewed left because it has that tail on the left side. Okay? But you can see that not just from these numbers. The numbers are not telling me that. What it's telling me is from that graph, right? The 5-number summary, the box and whiskers. It's showing This is where my tallest point is, and then it kind of just slopes out. Cool? Okay. Representing numbers. Okay, let's see. Oh, there's some more. You're probably thinking at this point, how much longer, Chad? I don't know. I don't know. I mean, technically, it looks like we got like 10 or 15 minutes, but we'll see. Let me look ahead a little bit. So, percentiles. Yeah, we're not going to do that today. Yeah, that's definitely another day. Sorry. Let's definitely do this question right here, and I might talk about it, but I probably won't do too much, if at all. Okay. So here we go. Box plot for construction worker and teacher. And so you can see that we got these box and whiskers here. Yeah. And you can see that this right here is the median versus here, this is the median. Okay. If Julie earns the salary represented by the third quartile of teacher salaries, third quartile for teachers, yes. So she's right here at 40. Okay. I'm going to say right here, 40, right? Then she makes more money than approximately blank other teachers. Pause. So if you look at this box and whiskers plot here, right? And I'm going to try to like evenly divide it like a sandwich. She's sitting right here, okay? And they're saying she makes more than all these other people right here, okay? What would this be if I had a perfect sandwich? How much percentage are we talking there? 75. Yep, 75. 75%. And again, percent. Okay, 75%. In a way here, remember that these are quartiles, quarters. How many quarters is she less than $1, essentially? That kind of thing. Or she's got 3 quarters. So what do we got? 75 cents. Kind of, yeah, I know, but that's how it works. Okay, but then they're asking about construction workers. So this is her line right here. She's at 40 right there, right? This is where she is. So then if you jump to this graph, how many folks are less? 50. Yep, 50. Because this is the median, but it's also second quartile, right? 2 quarters is 50 cents. So, yay, 50%. I mean, that's the math. Man, I just drew all over it now. We got another question about it. So if Mike, the teacher, and Jan, the construction worker, both earn the median, which one earns more? So again, we're looking like right here, and we're looking right there. Who earns more? Bam. There it is. Just looking at the graph, right? Cool. Wow. Okay. I thought that would take a little bit longer, but apparently not. So we got like 20 minutes. I won't be spending 20 more minutes though. Can we do a little bit of percentiles? Is that okay? Okay. So just a little bit. Any questions? If y'all have questions, I would, stop, talk, pause, and whatever you want me to do. So the difference between quartiles, I don't even know what deciles is, and percentiles is that you're doing 4 all the way to 100. And I guess if you see the deci, right, that means 10. But we don't use that in this class, so I don't really know. It's just there to kind of like show, I guess. Quartiles is definitely important. Percentile, very important. Okay. So I'm gonna have a small story for you. Yeah, I have small stories. This is real world application stuff, right? So I was, and I don't think I told you the story. I was taking a graduate level exam, and it was actually for the second time. So I had gotten into graduate school, I finished, and I started teaching here. I was teaching here for about like 7 years, let's say. And I said, well, let me take the exam again because I'm way smarter now. I've been teaching forever, right? So I go right in and I start panicking. I start freaking out because I know all the math, and it was a lot of statistics, and I was teaching statistics for like 7 years, okay? So I already know all this stuff. I know exactly what to do, but it's just I don't have a calculator. And I just know all the steps, but it takes so long, and I started panic attacking, and the timer kept ticking, and I just didn't know what to do, and all of a sudden, bloop, and it's gone. And I'm like, wow, I just totally bombed that. And then of course they had the English portion where I just did not care, and so I totally bombed that one. But I got my score at the end, right? And they gave it to me as a percentile. They said that I was 88th percentile. And you're thinking, oh, you passed with a B. No, 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 no. Okay, so let's talk about what that means, 88th percentile. We have all the people from 0th to 100th, yeah? And I'm right here at 88th. Okay, so that means I'm better than 88% of people taking that exam, right? Sounds pretty good. But the problem is, if you're thinking about it, that 12% people are better than me, and I'm their teacher. You see the problem? So it means something, right? It's not just passing, it's telling me where I'm on the curve. Yeah. So I did okay, but I could have done better. Anyways, so study for your exams. Don't panic. And use a calculator. So tuition costs in dollars, we got 25 different universities, and so what percentile is 26,000? I think that this one's a little bit weird because the numbers here are in thousands, so 26 is kind of the number that we're actually looking at. And so let's just say with this university has 26. So what percentile are we talking? Is it 26% that are less? Is it 78% that are less? Where would they fall? And so I have all these different numbers here, and I need to know where it would be. And here's the problem. I need to be able to cut this up and find out where the 26 is. Count how many are less than that. We can do it two different ways, guys. We could sit here for the next 15 minutes organizing it. You ever do this thing called a bubble search? No, let's not. So, or I could just simply start counting numbers that are less than 26. Okie dokie? And I think that'll be a faster technique in this case. Instead of having to list them all out, like here, wouldn't it start with 17 and then 19 and then what? 20 and then 23? Oh, but wait, I missed something. And it would take forever. So instead of going down that road, let's just see what is below the 26. You ready? We got this 1, 2, 3. If I miss something, you tell me 4, 5, 6, maybe 7, 7 or 8, 7 or 8. Okay, you know what? Let's call it. So 8. No, it says below, Chad. 7. So 1, 2, 3, 4, 5, 6, 7 numbers that are less. Yes. So right here, I'm actually going through this formula right here. We got 7, and then divided by, what's the total here? 25. Yeah, exactly, 25. Okay. Calculator. But y'all see how fast that was compared to trying to do it by hand? I really hope so, because by hand, it's not fun. There we go. Okay, yeah. So 7 divided by 25. We got 0.28. There it is. 28%, or rather 28 percentile, right? That's the actual one that they're looking for. 28th percentile. Sorry for the audio quality. Anyways, so 28% of universities would be less than that much right there. Okay, but then how many would be higher? $72. Could they put that on an advertisement and say, hey, I know we're kind of expensive, but 72% of other universities are higher than us? And you would say, oh, that sounds pretty good. So you can use that against, or for people. We do have time, guys. We have time. I want to keep going, and y'all are just okay. Look, how about this? Let's not do the tires. Is that okay? The tires take too long. Can we just real quick roll through this one? There's not even a lot of math. You just like point at it, okay? So the graph represents what's going on here. Test score represents what test score is at 62 percentile. Okay, so it says percentile right here. So I'm going to go 62. Oh, it's that guy right there. Okay, here we go. Give me a number. 17? You like 17? Anybody else? You like 16? 16 and a half? All those are right. I don't know. You can't tell. So on the homework, they have a big plus and minus range. If you're putting something in, it's gonna be okay. Okay. Exactly. If 2,000 students are taking the exam, how many of them are 60th percentile or less? Here, let's use a different color. So 60th percentile. Oh, right here. We just did it. What would you call that? Yeah, sure. 15.5. Yeah. And so 2,000 students are taking it. How many of them would be score? You know what? That's not helpful. In a way here, I found their score, though, didn't I? That was their score, but they didn't say how much their score was. They said how many students. How many students? What would I do then? What do I do? There it is, because the 60th percentile is technically 60%, right? Same thing. Times the 2,000. Wow, Chad, you were like throwing me off. Yeah, I know. Me too. I didn't know. There we go. So this is, again, students. Students. If 2,000 students, I'm going to wait for this one, is taking this, how many of them would score at or above the 95? So what do I do this time? What I just did. 95 times the 2,000. Bam! That is the big point. It's, yes, what we have is the 19 below, right? So then I'm going to want the above. So what would that be? 100, yeah. What? Get out of the way. Anyway, just leave me alone. Anyways, yeah. So what we're gonna do is the 2,000 that we had minus that 1,900, and so we got 100 that are above. Yep, exactly. Yep. And we're done. I'm not gonna do any more. Are we good here? Good. Thank you guys. Have a great day.